Right heading. Show that show that I RMS equals to I naught upon root 2. I RMS means square root of I average का square, correct? Hello? Root means square means what? Average of squares of all values ka square root. So it is written like this. Whenever it is written like this means average. Average of what? Squares. Its square root is called IRMS. So that means IRMS square will be I, which is I naught sine omega t square. I'm squaring both sides. So this root and this will get cancelled. So only square. Clear this much?
Yeah,
Hello?
sir.
Yes,
Okay.
sir.
Oh, sorry. IRMS is I square ka average and its square root. That means root of I is I naught sine omega t square. बाद में करता हूँ इसको. So this is I naught square sine square omega t. I naught sine square omega t इसका mean will become IRMS square. Now this is nothing but integral of I naught square sine square omega t dt for one cycle divided by dt for one cycle. This is very important stuff. Whenever you are taking average of any term, any periodic term, then you have to divide by time interval. That means it is denominator is simple. Dt integration is t from 0 to t. That means it is t minus 0, which will be equal to I naught square take outside. Sine square is 1 minus cos 2 omega t upon 2 into dt from 0 to t. So I naught square upon 2 integration of 1 minus cos 2 omega t from 0 to t, which is I naught square upon 2t. Integration of 1 dt is 1, sorry, t, and cos is minus sine 2 omega t upon 2 omega from 0 to t. Please copy this much. Hello, come here. Hello? Yes, come in. Hello, come in.
Yes, sir.
Every time you are late, whatever time lecture is there, only 5 minutes after that you come.
Sorry, sir. I was having dinner today.
No, that is today's okay, but I have found that regularly you are irregular. Why so?
Sorry, sir.
Okay. This we are doing show that IRMS is I0 upon root 2. So IRMS means average of I square ka square root. I means nothing but alternating source ka I0 sin omega t. Then its average is called integration for a half one cycle and then divide by time. That is what we have done here. This is integration 0 to t. Left side, can I clear it off? Left side.
Yeah, sir.
I naught square upon 2t. This is t minus sine 2 omega into capital T upon 2 omega minus 0 sine 2 omega into 0 upon 2. So I naught square upon 2t t minus sine of 2 into 2 pi by t into t upon 2 omega minus this terms will become 0. So I naught square upon 2t t minus, that is t will also get cancelled. So I square upon 2. Therefore IRMS taking square root will be IRMS is I0 upon 2. Capital. So two derivation we did. One was three derivation in fact. EMF induced in rotating coil. Then average is I 2 times I naught upon pi and RMS is I naught upon root 2.
Yes, sir.
So that in an AC circuit with pure resistance, EMF and volt current are in phase. In phase means their equation will be same nature. See, if something is like a sine 30 and other thing is a sine 30 plus 20, then we say this is leading by 20. If minus, then we say lagging. If 30, then we say they are in phase with each other. Okay, meaning clear of in phase?
Yeah, sir.
So we have to show that in an AC circuit with pure resistance, EMF and current are in phase with each other, or phase difference between them is zero. Usually in 12th standard board they say if circuit is purely resisted, EMF and current, phase difference between EMF and current. So because they are in same phase, so what is difference between their phase? Amen. What will be difference in their phase? Obviously zero, no?
Yeah.
See, when we say they are in phase, means they are together. So difference is what? Zero, no?
Yes, sir.
Consider an AC circuit with pure resistance R connected across alternating source of EMF E equals to E0 sine omega t. Let I be the instantaneous current. I be the instantaneous current. Therefore, I is voltage upon resistance, which is E naught sine omega t upon R. Let E naught upon R is I0, which is maximum current. So therefore, we get I equals to I0 sine omega t. Now, can you see equation 1? Left hand side is E, equation 2 I. They are called instantaneous. Maximum, maximum. Sine, sine. Same angles. What is phase difference? 0.
Yeah.
So I will write conclusion. From 1 and 2 we can say that phase difference between current and voltage in AC circuit with pure resistance is 0 or they are in phase with each other. Now draw the diagram and then write. Consider an AC circuit with pure resistance capital R connected across alternating source of EMF then comma equals to then T leg. Completed? Full?
Done, sir.
Right. From 1 and 2, from 1 and 2, we can say that EMF and current in AC circuit EMF and current in AC circuit with pure resistance are in phase with each other. Are in phase with each other. Hence, phase difference between them is zero. Phase difference between them is zero. Next, graphical representation of P and I with respect to omega t in pure resistance. Omega t is actually angle theta. So 0, pi by 2, pi, 3 pi by 2, 2 pi. This is E naught. I naught slightly less than that. Minus E naught and minus I naught minus E naught. So first EMF graph, then we'll draw graph of current. Maximum, 0, negative, back to 0. This is graphical representation of EMF and current. Then for current 0, maximum, again 0, negative, back to 0. This is EMF and this is current. Now in phase means both are simultaneously 0, simultaneously maximum, simultaneously negative. दोनों के height में फर्क है. One is E naught, other is I naught. Done this diagram, graph.
Done, sir.
Next is called phasor diagram of E, comma I across resistor. See, phasor diagram means vector representation of the graph. E and I, they are in phase with each other. So E naught is maximum value. It is E0 sine omega t. So it makes angle omega t with x-axis in anti-clockwise. So when you draw its component on y-axis, you will get E0 sine omega t. So again what I did, I have just drawn one ray at angle omega t. This ray is peak or maximum EMF, then its component on y-axis is E0 sine omega t. Now we want phase of E and I. E and I are together or forward backward? Together means they are in phase with each other,
Yeah.
but current is slightly less. So till this it is I naught. So this much becomes our ray diagram for I naught, and total is for E naught. I equals to I naught sine omega t. This is called phasor diagram. So for 1 mark they can ask you represent phasor diagram. Draw diagram. Understand meaning of what we did. We draw E naught anywhere at angle theta, which is omega t with x-axis in anti-clockwise. Anti-clockwise means positive. And at same place we have taken I naught on the same ray. Yes, done. This also.
Done, sir.
Next heading. Derive expression for average power dissipated in AC circuit with pure resistance. Karan, can you tell what is formula for average power in AC circuit with pure resistance?
एवरेज पावर is हाफ वो होगा ना क्या था?
या आप फॉर्मूला बोलो, मुझे फॉर्मूला
हाँ
चाहिए।
सर, एक सेकंड। पावर याद नहीं आ रहा सर अभी से।
याद आने के लिए क्या करूं? शंख पुष्प भेज दो, एक बॉटल, एक चम्मच रोज खाओ। Still you are not writing and practice, it seems. Please write and practice everything.
Yes, sir.
Kamya, you know what is formula for average power in AC circuit with pure resistance?
Is it VRMS by R?
E RMS into I RMS. This formula. We will check whether it is true or not. Can I say power is rate of doing work? Can I say like this?
Yeah.
So can I say dW is P dt by cross multiplying? This also we can say, correct? No?
Yeah.
Average means total work done upon total time will be called average power. This is small work done. So total work done upon total time for one cycle will be called average power. Now this dW is P dt I will write. Okay.
Yeah.
Now please write the heading so that I can complete entire derivation in this on the screen. Done? Shall I clear now? Heading? Heading you all have written now?
Yeah, sir.
Yes.
We want expression for average power in an AC circuit with pure resistance. Few of you were knowing the formula, not correct. It should be ERMS into IRMS. Let us see how. Average power dissipated, comma P average is integration of dW for one cycle upon dt for one cycle. So this formula basic I have to remember first. Now I'm starting from beginning. Consider a resistor R connected across alternating source. Let E comma I be instantaneous EMF and current. Therefore, E equals to E naught sine omega t and I equals to I naught sine omega t. Instantaneous power P equals to EI, which is E naught sine omega t into I naught sine omega t. So E naught I naught sine square omega. Average power dissipated is work done for one cycle upon time for one cycle. So work done is P dt from 0 to t integral of dt for one cycle. So this is E naught I naught sine square omega t dt from 0 to t. Integration of dt is t from 0 to t. So E naught I naught sine square is 1 minus cos 2 omega t upon 2 dt from 0 to t upon t minus 0. Please copy till this.
Done, sir.
Can I clear off again? Is completed full, Karan?
Done, sir.
Yes, sir.
So further it will be E naught I naught 1 minus cos 2 omega upon 2 to outside. This is t inside t minus sine 2 omega t from 0 to capital E naught I naught upon 2t t minus sine of 2 omega 2 pi by t into t. This is upon 2 omega upon 2 omega. Minus of 0 minus sine 2 omega into 0 upon 2 omega. This is cancelled. E0 I0 upon 2t into t minus 0 minus 0. This will become E0 I0 upon 2t into t gets cancelled. So E0 upon root 2 I0 upon root 2 we can write for 2. So final answer E0 upon root 2 means ERMS. I0 upon root 2 is IRMS. So P average equals to ERMS into IRMS. Complete further. Done full. P average is PRMS into IRMS.
Yeah, sir.
Okay. So we have done resistance full. Then second part is coil and third part will be capacitor, then combination. So today we stop here. Please revise and keep this ready again when we are meeting in the next class, that is on Monday. So every Monday, Wednesday, Friday is your lecture. Coming week will complete and then I will do revision.
Okay, sir.
Okay, sir.
Okay, that's all for today. Bye.
Thank you, sir. Good night.
Thank you.